applications. So web applications.
Okay. Thank you. Thank you, Terry. Good morning again, all. It's a pleasure to be here today to make this particular presentation. Now, as the topic is security threats, mitigation, and frameworks for cloud computing applications, it's basically a theoretical review, but it will give more of, in terms of the history or at the current level of cloud computing, its applications, and also in terms of challenges which are being faced within the environment we are in terms of security, because security has been one of the critical issues facing most of ICT-based or information system-based applications worldwide. Therefore, for starting, we can say that so the cloud is an internet-based computing technology, right, that allows an infinite number of servers to act as a single entity. Thus, it can be called being a distributed computing system, right? Computing tasks are assigned to a combination of remote connections, software, and services on demand. That means that we can connect differently from different remote areas and distribute services. And services, we can call them like functions, right? So you can access a particular function, while another client can also access a different service at the same time. Therefore, we say end users no longer need expertise in or control of the technology infrastructure, right? In the cloud, that is in the cloud. And in this is why there is a renewed optimism in the clouds of Africa and in the developing world. So cloud computing offers several advantages, such as flexibility and scalability, enhanced server uptime, promote group collaborations, competitive edge, and cost effectiveness. Because we are comparing cloud computing vis-a-vis played a key role in the private sector's productivity improvements in industrial countries by automating innumerable business processes such as accounting, human resources, and customer relations management systems. And that means that information systems are able to automate both core activities and support activities in any business setup. So in turn, this automation has increased efficiency and triggered high growth in industries ranging from investing banking to farming and revolutionized small and medium scale businesses, which make up to 90% of enterprises globally and account for 50 to 60 of all employment in these particular countries. Therefore, in contrast, small and medium scale businesses and large scale enterprises in Africa and in the developing world have not fully benefited from the technology revolution because of the expensive upfront costs of buying hardware and software, managing IT on-premise, and more importantly, the lack of which have prevented the development of supporting ecosystems similar to those available in the industrialized world. So additionally, the internet has generally not been available, and when it was, the cost was high, speeds were slow, and access was unreliable, and therefore not practical to the majority of African firms for managing their businesses over the cloud. So continuing on this, we can say that over the last 10 years, African countries have made major investments in the ICT infrastructure landscape. So So the region presents a large growing market that is increasingly connected via mobile technology and broadband connectivity. This is critical as lack of effective communications infrastructure has traditionally been one of the biggest obstacles to cloud computing adoption. At the same time, Africa is getting increased broadband access to the internet, and it's projected that the new cables will help reduce broadband prices by up to 90%. Therefore, at this stage, the stage is set for mass adoption of the internet across the continent by combining rapid penetration of cellular technologies with increased access to the internet. Right? So, independent software developers, that is ISMVs, in the developing world must develop applications that meet local realities, not those that work in the developed world. For SMBs, that is small and medium businesses, the traditional paradigm of procuring IT was to buy their own software and hardware. So the SMB only currently, with the cloud computing technology, the SMBs only need a good internet connectivity to remotely access the IT infrastructure that is located in the cloud provider's data center. So the cloud provider can offer access to IT services for a lower cost than on-premise IT infrastructure, thus lowering the entry cost for many small and medium enterprises. So let's look at the problem statement at this point. So the problem is this: at this moment in time, when small and medium-scale businesses and large-scale enterprises face an economic downturn, the labor and capital required for standard servers and licensed software may be prohibitive. An accelerated shift to the cloud seems inevitable. With maturity of cloud computing in the year 2019, still a key cloud concern also for late adopters in Africa. Cloud providers achieve economics of scale by providing or by building a large data center and then sharing resources to all the customers. Due to the shared environment, customers' information and data are exposed to all forms of vulnerabilities and threats. There is a need for provider to ensure that every customer is identified and that none should have the ability to see or change another customer's data. Organizations are worried on how to develop adequate mitigation strategies for effective control measures and to balancing common expectations between cloud providers and cloud users. Therefore, the objectives of this study are to identify common threats in cloud computing, to provide threats mitigation techniques in cloud computing practice, and thirdly, to propose a framework or frameworks for identifying vulnerabilities in cloud computing applications. So, you can hold it there. So we move.
Yeah,
we can move. That is introduction of faulty applications or infrastructure components. Okay. So when you look at the third threat, which also is identified, is availability as a threat. That to do with change management. Okay. So change management, you look at customer penetration testing impacting other cloud customers. Okay. And the second one is infrastructure changes upon cloud provider, customer, and the third-party system impacting cloud customers. Okay. Then another another threat which arises from the threats on availability is denial of service threat. And these ones we look at them are network bandwidth distributed denial of service, network DNS, domain name service denial of service, and the third one is application and data denial of service. Okay. So when you look at threat mitigation techniques and tools of all those particular threats are identified. So some of these tools are, some propositions have been made in such a way that the current capabilities of the cloud are not curtailed while limiting the cloud provider control on data and enabling all cloud users to benefit from the cloud. So one of the tools and the techniques used is information-centric security. So this one is, we say, in order for enterprises to extend control of data in the cloud, it may be worthwhile to take an approach of protecting data from within. So this approach is also known as information-centric security. Okay. The other part is high assurance remote server verification by use of trusted computing environment. By the way, when you're talking about information-centric security, we can look at an organization initiating encryption protocols within that particular organization. So you can either have on or proprietary made data encryption protocols. So in that case, we call it information-centric security. The other part is high assurance or other mitigation technique is high assurance remote server verification by use of trusted computing environment. So a trusted monitor is installed at the cloud server that can monitor and audit the operations of the cloud server. So a trusted monitor can provide proof of compliance to the data owner, guaranteeing that certain access policies have not been violated. So in this case, you put an independent application which is going to monitor, which is going to be a firmware or a middleman in between the organization and the organization which owns the data on the cloud and also the cloud service provider. So you have a monitor in between. So that basically provides a proof of compliance, right? So the other mitigation is providing privacy-enhanced business intelligence. Privacy-enhanced business intelligence. So a different approach for retaining control of data is to require the encryption of all cloud data. Use of searchable encryptions also refers to as predicate encryption. Now, when you're looking at predicate encryption, is that this data is no longer now on transit. Now you're looking at a resident data. Now, when you're looking at the resident data, you provide searchable encryption, because when you encrypt data, when you encrypt any data, then you're not able to search within unless you decrypt that data. But when you install a searchable encryption, which is called predicate encryption, therefore the data is encrypted, but you can still do other searches on that particular data. That is one of the techniques which you can use in the sense that the data is encrypted, but that organization can continue access of that data, whether as far as is being hosted on the data center where the service by the service provider. The fourth one is having a virtual private networks. When users connect to the internet from home or any public place like airport, hotel, etc., then he will be assigned or signed into his virtual private network and get secure communications, right? So you can create virtual tunnels in that case, where you can be able to access, or you can privately be able to access some of data securely. The fifth one is installing an IPsec or Internet Protocol Security, and this encryption between browser and web servers. It usually provides enough security from the workstation to the browser. So in this particular case, you are installing or you are encrypting your data on the browser's interface. Okay, so you have internet security from the browser's level on within the protocols of access on the computing network, right? So you have that particular security protocols within that particular level. So the other part or other tools or techniques is basically having intrusion detection systems, right? So intrusion detection systems, you detect any threat which is currently occurring within your system, okay? But you don't you preempt. So you have a system where you can you have already an attack, so you can basically detect an attack which is already occurring, not to preempt an attack before. The other part is service management, which is called SPAS. Now, let's look at the final objectives of the study is having a framework for addressing software vulnerabilities. You realize that when you have the tools and techniques and tools for threats prevention, they are more of end-user based tools and techniques already on an application which has already been installed, already running in an institution. But also we need to preempt threats before they occur. And the best way to do this is having particular applications or methods which can basically scan those particular applications before they are introduced to the customer or being used within the particular cloud application. So in this area, we found five base relevant frameworks for assessing, monitoring, and alerting instances of suspected exploits and attacks for known and unknown compromised security, privacy, and integrity in cloud environment. Because before you do any attack, first you have to exploit any vulnerability. Therefore, if you have a way of blocking or identifying all those particular vulnerabilities, then much safer from any attack. So the first one is we have automated patch generation, right? ATG, right? Automated, and this one is more of a machine-based, automated, machine learning-based technique. Patch generation is to use a combination of machine learning and program analysis techniques to learn those human knowledge from success of human patches widely available from the web. So for example, we have this. So in this case, we are saying that we can create we have already a machine learning technology or application which learns or identifies what most patches which have been basically been made by people or from humans, and then that machine language or that machine application will compare what is in the current application and what are the possible vulnerabilities and also patches which have been generated previously or reused previously. Then it will use those particular patches on the current application before even that particular application is being used in the market. So in this case, we have that particular diagram. We are looking at high-level design. We have a buggy program on the right, which has more bugs, and then we have patches from a big data or big code database. So these are the other possibility or other solutions on that particular problem. So it searches that. Then that particular application will or this particular application, which is automated patch generation, will basically patch that particular program. What you say, the candidate patch ranked by model, then validate with test suite, right? So it's going to patch that particular program. That means the system is, as long as also the system is running, so there's always an automated system which runs on the background to search for the possible solutions and patch that particular program. The other one is shield generation or shield gen. So a system for automatically generating a data patch, right? A system for automatically generating a data patch for a known vulnerability, given a zero-day attack instance. So when you're saying a zero-day attack instance is where first, if you're attacking a system, you identify the vulnerabilities, then you give it that system, you give yourself some time, then after some few days, then you initiate now the attack, a full day. So we call it a zero-day attack because you have to identify those particular vulnerabilities. They have cloud deployment models overview, and these cloud deployment models is a specific configuration of environment parameters, such as the accessibility and proprietorship of the deployment infrastructure and storage size. This means that deployment types vary depending on who controls the infrastructure and where it is located. So we have basically 4 types of deployment of cloud computing systems or applications. So the first one, we have public clouds, private clouds, community-based clouds, and hybrid clouds. And so we can look at applications in cloud computing. So the first of applications which you can look at is e-learning clouds, right? For particular institutions. So in e-learning clouds, we have service delivery such as email, simulation tools, file broadcasting, class recordings, virtual classrooms, virtual labs, surveys, and education forums. Further, we can look at other applications of cloud is in e-governance cloud, and this is where we say complaint resolution systems, employee management systems, e-policing, e-tendering, e-court, payment and tax systems, agriculture and food, industry and energy. The other part is enterprise resource planning or ERP clouds. And in this, you can apply cloud systems which are based on supply chain and vendors, project and human resource management, further, and customer relations management. So these are particular areas where you can basically apply our cloud computing. Now, some of the security issues which arises in cloud computing, that is security and privacy related challenges in cloud computing. So there are numerous security issues for cloud computing as it encompasses many technologies, including networks, databases, operating systems, virtualization, resource scheduling, transaction management, load balancing, concurrency control, and memory management. So there are 6 specific areas of cloud computing environment where equipment and software require substantial security attention. So the first one we can have, the first one is data at rest. The second is data in transit. The third is authentication. The fourth is separation between customers. The fifth is cloud legal and regulatory issues. And the sixth one is incident response. So we are going to look at our response, or we're going to manage our security issues around the 6 areas identified as key areas of security threats around our cloud computing applications. So, so the first one, we're looking at the cloud threats, right? So cloud threats. So application vulnerability only represents a potential avenue of attack. An overview of threats for cloud customers are categorized according to the, basically categorized depending on confidentiality, integrity, and availability. So security model and their relevance to each of the cloud service delivery model, right? So just to go to brush over, when you're looking at confidentiality as a threat, you're looking at malicious cloud provider, right? User, or we say malicious cloud provider user, malicious cloud customer user, malicious third party user, okay? That is from the internal issues, threats on confidentiality. When you're looking at external confidentiality issues, you look at remote software attack of cloud infrastructure. Remote software attack of cloud infrastructure or applications. Remote hardware attack against the cloud. And also you can look at remote software and hardware attack against cloud user organization, endpoint software and hardware. And then you can have, or fourthly, you can look at social engineering of cloud provider. And so we have that. You can also have data leakages as issues to do with confidentiality. So when you're looking at integrity as the second threat, we look at data segregation. So incorrect defined security parameters. Okay, when you're looking at integrity as integrity threat, but looking at data segregation. So incorrectly defined security parameters. Second, incorrect configuration of virtual machines and hyperversions. Then we have user access, poor identity and access management procedures. The third of the issue to do with data integrity, then initiate a full attack on that particular system. So we say we can initiate a system which can identify unknown vulnerabilities, okay, within that system which has been developed. So the key novelty in shield generation is that it leverages knowledge of the data format to generate new potential attack instances and use a zero-day detector as an oracle or a vision to guide the search of vulnerability signatures. So in this case, we are saying that every attack must have a particular signature, or every vulnerability has a particular item which can be identified as if this vulnerability, if you want to attack this particular system, then you can attack this system using this kind of file format. So if you can identify those file formats, then you can create solutions, or you can basically patch those particular issues or those vulnerabilities so that such files cannot be used as an attack on that particular system. So we have that particular drawing or that particular diagram showing that. So you have an oracle which basically creates like a vision, right? It has a storage, something like a knowledge. Then you have data format, which analyzes all the kind of data format which can be used. Then you have an oracle, you can also look at as a database for that case, right? So in that case, we have all that. Then you can probe generator and analyzer. So the probe generator, you can continue probing those particular vulnerabilities and also at the same time initiating their patches. So we have a data patch at the same time patching those particular vulnerabilities. Now, so the other techniques or frameworks which are also being used or can be used is zero-day attack signature management infrastructure, or ZASMIN, is a system that provides an early warning at the moment the attack starts to spread on the network, and to block the spread of a cyber attack by automatically generating a signature that could be used by the network security appliance, such as intrusion detection system. Therefore, when you're looking at the zero-day attack signature management system, is more of an intrusion prevention system, right? So it identifies that particular signature of a particular attack. Then it tells a particular user this is the signature or the issue which is being, or this is the particular file format which is being used to attack your system. Therefore, that particular user can initiate an intrusion detection. We say now we can use now that one to do a prevention on that particular system. So we are saying, we are saying that safe attacks by automatically generating a signature that could be used by the network security appliances such as intrusion detection systems, IPSs, right? So you can use for that. So when you're looking at intrusion detection systems and intrusion prevention system, so when it initiates that, it has initiated that, it has detected that particular file or that vulnerability or a signature, then the intrusion prevention system now also comes into play to prevent that kind of an attack. And the other one is polyvaccine. So polyvaccine is concerned with the threats related to binary code injections through HTTP requests and addresses zero-day polymorphic and metamorphic exploits. So polyvaccine does not address non-binary code injection exploits using scripts, languages, or SQL statements, or exploits that do not perform system calls. Now, when you are looking at polyvaccines, you are looking at those particular a prevention or a technique which basically looks at those systems which are going to call. Like if you're looking for worms, a worm basically calls for an action. It's a system call. A worm calls for a particular action to be taken. If you want to delete all the files with this kind of a signature or file formats. So it always calls for an action as a continuous action. So when you're looking at polyvaccines, basically look at those kind of particular vulnerabilities, right, or threats which have a call, which are going to call for a different action as a continual action, right, within that particular system. Okay, so it's going to look at those particular issues or threats, and you'll find most of the system calls are injected through HTTP protocols, right, or HTTP requests, right. So when the polyvaccine basically address those kind of issues. The other part is Customer Security Control Framework, or CSFS. This one is designed to help users secure their systems with a list of mandatory controls, community-wide information sharing initiatives, and security features on their payment infrastructure. So the CSFC is designed to evolve based on threats observed across the transaction landscape. So the CSFC's controls are centered around three overarching objectives, that is secure your environment, know and limit access, detect and respond, right? So this one, when you're looking at Customer Security Control Framework, is more of a framework based on financial transactions. And those particular transactions which runs across different institutions, then you have to have a particular standard on how those particular transactions, they have to be activated or transacted across those particular networks. So in that case, you have three levels of controls. That is secure your environment, then you'll have standard and policies to address those particular environment. The second part is know and limit access. You have standards and policies to address and limit access of transactions or the systems being used. And the third one is detect and respond, which is really the last issue in this, because the first two are failed. So the final one is detect and respond framework. So we have looked at those particular frameworks which are used by an application developer, or at the end of the day, an application developer, and not the end user, not as the end user. So for future research on this particular area, we say more research is desired on the legal framework of cloud adoption in developing countries. Because one of the issues identified is that there is no legal framework on implementation of the cloud and also responsibilities. Who bears responsibilities on the cloud? Because each player or service provider comes to they have their own policies concerning that. So there is a desire or there is a need to develop a legal framework adoptable within a particular environment. So this research can be a good starting point for researchers to carry on a focus study on applications of cloud computing fit to current environment. Then the second one, or the final one, is this can also be a possible direction for future research to thoroughly investigate development of security frameworks based on machine learning and artificial intelligence. Because what you have looked about on the several frameworks are based, some are based on machine learning, but there is a need to expand these machine learning frameworks to fit into the artificial intelligence. I think that's the end of that presentation. Thank you.
Thank you very much for such a nice presentation. The floor is open for questions. And I have one question.
Yes.
Regarding artificial intelligence.
Yes, yes.
It is quite an interesting area these days.
Yeah.
But, in your view, how long do you think it will take for Kenya, for example, to adapt the concept of artificial intelligence and cloud computing, and how cost effective is it?
Okay. So let me start with the first one. How long do you think Kenya will take to adopt cloud computing? Currently, we're having more organizations. As we discussed initially, said because of the infrastructure issues. Infrastructure issue was one of the main issues to do which drives the adoption of cloud computing. Now, we're having a lot of fiber which is being laid around the country. So that creates the first ground for adoption of cloud computing. Then the second, we have also the government, which has come forward by creating its own data center, where most government institutions, they can migrate their data from normal brick and mortar kind of infrastructure to more of cloud computing infrastructure. If you look at Kansas City and all that, so there's a lot of data center there, and also companies like Safaricom and these multinational companies, because they have also started setting up data centers. So most companies, they're also starting now to see the importance of having their ICT infrastructure on a cloud computing, because it's much cheaper and most cost effective, right, on that particular area. Then the third one you asked about is artificial intelligence, right? So how far or at what level we are at currently. Artificial intelligence, I can say we have some applications which are basically using artificial intelligence depending on the area of specialization, right? But when it comes to the level of security analysis and mitigation, we are still far backward when it comes to that level, right? Because what we are using currently in artificial intelligence is not on security issues, it's more on on system performance and data analysis. But we have not used artificial intelligence on security analysis and mitigation applications. We are not yet there. It's still under a lot of research which goes around artificial intelligence and security, not on computer security, not when it comes to human security, although because we have artificial intelligence for facial recognition, data analysis, all that one, but not in when using on computer security analysis on systems. Yes.
Thank you very much for the question. The platform is also open. If you're online, please feel free to ask a question on the public chat. And this is a very interesting talk on cybersecurity. Any other questions? I'll ask the last question.
Yes.
Okay, on Kenya University and your research.
Yes.
With regards to, there are a lot of spam journals, or rather we call them, there's like scavenger journals. A lot of upcoming journals that are not genuine.
Yes.
Or conferences, a lot of conference invitations that are not real.
Yes.
How is it possible to be able to block such, especially for the young students and undergraduates, so that they are not targeted
Yes.
towards those spam journals and conferences?
Okay. Fine. Now, when it comes to some of that particular issues to do with protection, let's say it's more of data protection
Yes.
and proprietary data protection. Now, from the scavenger kind of journals, if first of all we can look at everything is guided by standards. So we can look from, let's say, Kirinyagas. The institution first of all can scan, right, all of authorized or authenticated kind of journals, because we have some organizations which basically authenticate predatory and genuine journals. So the institution can come with such, then can say this is what if you're going to publish, these are the authorized kind of journals you should be authorized. You can basically, you're authorized to publish your research in. So the other one is more of if you're going to use systems, right? Systems to manage this kind of predatory journals. We can have what's called, we can have a standard, and from that standard we have coding, right? Coding for all genuine journals. But now this one comes of is a multifaceted kind of initiative, right? So such that we can have all the genuine, or if a journal wants to start publishing or go online, then it must have this kind of signatures, right? What we call a digital signature. We can look at a digital signature. So such that this digital signature is only accessible, or only if you want to start a particular journal, you can only buy, right, or access that signature from an authorized body. When you have that authorized body, then it's able to control most of these particular journals. And if your journal doesn't have such a signature, then it's going to be basically flagged as a predatory kind of journal. That is what I can answer at this particular moment. Yes.
Thank you very much. Thank you very much for responding to the questions. Any other questions? Thank you so much, Mr. James. We are grateful for such a timely presentation.
Thank you.
And thank you, members, for giving us an audience and also for listening. Thank you.
Sure.